Hi everyone, and welcome to this video. So this is probably going to be a series of videos, and it's based on comments I've had on a video that I did on data analysis, and it seems that it's a pretty popular topic for sim racers and real racers alike. Want to know more about analysing data, and so it got me thinking that I ought to do a series of it. But one of the things that sort of came to mind was it's very easy to use data analysis and compare to better drivers, but for a lot of us sat at home racing alone on sims, we don't have access to another driver's data necessarily. It's not something that we're likely to get from our competitors, and if we haven't got something to compare against, then we do have tools that we can analyse our performance with, but a direct comparison is obviously going to be easier and potentially better because we know what the performance envelope is that would make us competitive. So I also wanted to show off a lap time simulation tool that probably a lot of sim racers have never come across before. It's something that professional teams use. The one I'm going to show you is a free download. It's not super accurate, but it's quite good in terms of its consistency and for what we want to use it for. The professional ones that we use when we're working with pro motorsport teams are hideously expensive and much more complicated to use, and so pretty much out of the realms of what a sim racer is likely to use. Anyway, so that piece of software is called Optimum G. It's called Optimum Lap, but it's from a company called Optimum G. And Optimum G provides software tools to pro motorsport teams. Simulation tools, basically. Not our sort of simulation, more computer tools for analysing potential, analysing tyres, suspension geometry, that sort of thing. And they've got this software, Optimum Lap, which is really a basic demonstration of lap time simulation. They say it's accurate to within about 10%, and it gets pretty good results, and for us sim racers it will be quite a useful tool. Show us a few trends, probably highlight a few areas that we're missing out on. So okay, the first thing you want to do is download Optimum Lap, which requires you to go to optimumg.com. I'll put the links for these in the video description. Need to put in your email address and sign up. What you'll get is a confirm your email address type email, and you'll get a code license key to run Optimum Lap. To run it, just obviously double click the icon that it puts on your desktop, and you get, let me start a new one. And you get this blank project. Now you can create a car and you can create a track. For the purpose of this video at the moment, keeping it simple, we're going to import a car and have a look at that. We're going to import one of Optimum Lap's tracks that they've already built for us. So you can click on the icon and browse for a car that they've already modelled, which, because my internet's really slow at the moment out here in the garage, I'm going to close that, and I'm going to load one that I already downloaded, which in this case is a 2012 Porsche 911 Carrera S, and I'm going to import a track that I've already downloaded, which in this case is Brands Hatch Grand Prix circuit. If we take a look at the double click on the vehicle name and you get all of the data that they've used to build this car. So overall mass, aero data, tyre data, engine torque curve, a few bits and pieces that I don't play with, gear ratios, final drive ratio, driveline efficiency, and then some scaling factors. And these scaling factors allow you to quickly change things like the amount of power that you've got, the amount of grip that you've got, and your drag and downforce values in proportion to whatever values you've got in the rest of the tables. If we have a look at the circuit, so the circuit, they make it up from straights or segments. Straights are segments with very large radiuses, corners are ones with smaller radiuses, or straights that have like infinite curves if they're dead straight. There are ways to generate these tracks from data, I believe, but Optimum G have already got plenty of tracks pre-built. So essentially, to take this Porsche 911 round Brands Hatch and see what it says about lap time, go to simulation and simulate. You can have more than one car and more than one track loaded, at which point you can select, what combination of things it is you actually want to simulate. But for us, it's Porsche at Brands. So simulate, and then we can generate a series of graphs of predicted, in this case predicted speed against lap distance, and it predicts our lap time as being 98.14 seconds, so 1 minute 38.14 around the full Grand Prix circuit. And then the idea is, if we said what would happen if we made our tyre grip a bit better. We can rerun the simulation and we find, oh look, we're 8 seconds quicker. And then if we look at the speed traces, we can see, as we would expect, the change made, higher minimum speeds in all the corners, better, faster exit speeds resulting in higher top speeds. So you can play with stuff like that, and it's quite a good thing just to play with and see the scale of difference that different changes make. I'll put that back and I'm going to delete that because that's a bit of a ridiculous change to make on such a car. But anyway, for the next point I wanted to make was we can now export these results. We can, by clicking export results, and it exports it as a CSV file which can be brought into Excel, but more importantly it can be brought into some other data acquisition or data analysis software, so you can compare it against laps that you've got on the sim or laps that you've got from a real car. Select the lap that you're interested in and press OK. Save it somewhere. And that is saved, ready to bring into an analysis program. Now there's the issue is that a lot of the sim titles tend to work with data acquisition or data analysis software like this from MoTeC, and the problem with that is MoTeC charge you for the ability you have to buy a license to bring in CSV data, and it's actually quite expensive. It's several £100s a month to be able to do that. But they do allow you to find a data file. They do allow you to export CSV free. So the first thing that you could do, without doing anything in theory, is to bring it into Excel or another spreadsheet. You can actually open it with Notepad. And this bit from the simulation results down is your CSV file of the data from that lap that it simulated. And likewise with the MoTeC data. Right, okay, so now we've got ourselves some data to compare against our own driving. There's a couple of issues. I just wanted to introduce like that method, and now I'll just talk through the issues with it. So this, for example, our Porsche 911 Carrera S, someone else has modelled that for us. We don't know what values they've got. We don't know whether they're right. And also the same with our sim model. Somebody else has built that sim model, used physics data from Lord alone knows where they've got it from. They're usually pretty good because like lap times and feedback from drivers that have driven similar cars compare well, but we don't know whether they're or how the two correlate, and they need to correlate in order for this data to be as accurate as possible, and therefore provide good comparison and show us the way to improve our driving. The good thing is that the sim model data output into MoTeC will give us a few hints. We'll be able to find, let's have a little look, for example, at lateral acceleration. Right. So here we've got lateral acceleration against distance around Brands Hatch from the Optimum Lap output, and we can see lateral acceleration is 12 meters per second squared, which is essentially 1.2 g. And when you look here, longitudinal friction, lateral friction, 1.2 g. So if we now look at MoTeC and a lap that I did in a Porsche model in rFactor 2, if I now, so just to recap on MoTeC, open it up, select a workspace, let's close it down and go through it properly. Open it up, select a workspace. You can do file open log file, or use this folder with the plus sign, or you can go to data, and again you've got the folder with the plus sign. Open in rFactor 2, it will be saved in the log folder, which you can find from your rFactor 2 folder, which if you need the full path for, in this case because I've got a partition hard drive, it's under Steam Library, Steam Apps, Common, rFactor 2. If you're in haven't got a partition and it's installed it on your C drive, you'll find it in C, Program Files, Steam, and then it will be Steam Apps, Common, rFactor 2, and then Log. Select the outing that you're interested in, so I'm just going to select the last one that I did. And at the moment I've got displayed, actually I'll go back to the first tab, so that's where it's got most of the interesting information. On this first graph I've got engine RPM against lap distance. If I press F9, it goes against time, like lap time. I'll stick with distance. The next graph shows the speed, car speed. The next graph has an overlay of throttle position and steering angle. And then the lower one, longitudinal and lateral G-force. Lateral G-force in the turquoisey colour. So if I click on one of the traces, one of the graphs, I get this guideline, and the values against the label tell you what the value of that is at that point. So for lateral G, at the moment we've got, at this point on the circuit, 0.19 G. So I can go round and I can look. So there's a high number in one direction, showing that we're pulling 2G at that point. And I can check, and there's another high point, 1.7G. I can find another few high points around the circuit, and we've got 1.5 there. And lastly, down here, another high point, 1.6. So it's fair to say that this Porsche model will pull somewhere between 1.5 and 2G. Just check where it is there. 2G, yeah. You have to be a little bit careful because curb strikes might make these values higher than they would normally be, but I think 1.5, 1.6 looks about right. So we can put in our Optimum G, we can change this longitudinal and lateral friction to be 1.6, and we can run the simulation. As before, we've knocked a clear 10 seconds off our lap time now. So we're now down to a 128 around Brands. Because our sim model, our rFactor 2 model is a GT3 car with downforce, 1.6 G is quite likely to be correct. Let's have a little look at longitudinal G under braking. 1.4 G here, 1.5. Maybe I'm just not braking hard enough. It's got a little bit of a balance problem, this model. So that's about right. So there's one data element we can get from MoTeC to make our OptimumLap model a bit closer to our sim model, and therefore give us data that's more accurate for comparison. Because obviously the lap time simulation software is essentially a perfect driver, so we can take our perfect driver and compare him with our own performance and see where we can improve. And what I want to say about accuracy is they claim it's within 10% of the real car, so it'll be, one assumes, within 10%. If we manage to copy over as much data as we know about the sim model into this software, then we know that this lap time and these data points should be within 10% of our time in the sim model. Now, that might not seem particularly accurate when we overlay our data. However, that is still very useful, because if we find that around the majority of the circuit we are within, or we are close to being within 10% of what Optimum Lap tells us we can do, and there are some areas of the circuit where we're, say, 20% different, then because this is a computer model that will have a consistent error in it, we can focus on those areas where we're further than 10% out, knowing that the difference is in our driving. And so we can start to look closer at the data that comes from Optimum Lap, compare it to our own, and see what it is that we need to change to make ourselves go quicker. Now, the next thing that's possible to make this model more accurate is to take a look at the actual data that builds our rFactor 2 model. Now, in rFactor 2, we have the luxury that a lot of the models, or the mods, are open, and so we can get to the data to check. And also, there are certain elements of the data that will come up in the garage section of the model. Let's have a quick look at, for example, at gearing. If we go into rFactor 2, and if we go to the garage section, here we've got our gear ratios, and we want the inverse of this value. We can use these teeth in and teeth out numbers, divide one by the other, and our final and reverse, same here, divide one number by the other for our teeth in and teeth out, and we'll get the values that Optimum Lap needs to put in here. At which point we've then improved our accuracy of our lap time simulation model, and I'll take you through looking at getting more of this information out of the physics in a separate video, because it's not overly complicated, but there are plenty of steps to it, and it's deserving of a video on its own. And I think it will benefit people that are looking to mod models as well, especially real racers who want to make their car more, or their sim model more like their real car. So please have a play with Optimum Lap. It's a good program. It's relatively straightforward to use. Hopefully I've demonstrated that. It doesn't require an awful lot of data, and some of this data is available, like, for example, drag coefficient. You can look that up on Google, and you should find a relatively close estimation of what a Porsche 911 Carrera S drag coefficient is like. Downforce coefficient might be difficult to find, but there are plenty of these example cars on the Optimum Lap website that you can take a look at. I'm sure you'll find something that's close. And also you can use these sliders down here to fudge it. So if we, for example, were to go to analysis speed, if we were to take this data and find that once we've put our gear ratios, once we put everything in that we know we can get either from MoTeC or from rFactor 2's like garage section, if we haven't gotten into the physics and got the rest of it out, we can make some guesses, because all you need to do is pull up some graphs, and for example we can look at the rate of acceleration, i.e. the difference between this low speed or lowest speed point and this highest speed point at this section of the circuit. We can compare that to what MoTeC gives us at the same point of the circuit, which would be probably here to here, I would guess. It looks flatter just because the lap is spread out in MoTeC. And we can use our fudge factor sliders down here at the bottom of these tables. We can change our power factor to try and get those to overlay more accurately. And once we've got those sort of areas, once we know that our rate of acceleration matches quite well, if our top speed's matching well, we know that our aero can't be too far away, and know our gear ratios are correct. If our lateral acceleration graphs, the peaks and troughs, if you like, are looking similar, then we know that our model will be quite close, or that our two models will be quite close, and then we can start looking at the finer details to compare our driving. So okay, I'm going to stop it there for now, and in the next video we'll take a closer look at how we get our two CSV files in somewhere that we can overlay and compare them, and in another video we'll take a look at extracting the data from rFactor 2 to plug into this lap time simulation and get more accurate results, or a closer correlation between the two models. So thanks for watching. Please like and subscribe. Getting close to 1,000 subscribers now, which releases some extra tools to make better videos with. So would really appreciate it if you subscribe. And finally, thanks for watching.